All right, welcome to another chemistry lecture. So today we're going to be talking about this thing called dimensional analysis, or DA. And really the purpose of this process is to be able to organize your math work when you're doing conversions. Some of them might be kind of simple and you might think, oh, I could just kind of punch that into my calculator, and some of them get pretty complicated, so that it's nice to have this organized way to kind of set up your problems. So that's what we're going to be working through today. So we'll have I'll do a couple intro things, and then you'll sort of practice it on your own and come back and check in and kind of go back and forth like that. Let's go ahead and get started. So this idea is that it's called dimensional analysis, or DA, and kind of think of it as like chemistry math. Here's the process that you're kind of going to go through when you're trying to solve a problem involving conversions. The first thing you want to think about is, what number and unit are you given? This is your starting place. So you might hear, someone ask you, oh, like, what's your given? Where are you starting? You need to have a starting place so that you know where to continue. The other thing is that you want to know where you're going to end up. So what unit are you trying to get to? So if you're given centimeters and you're trying to get to meters, that's important. Or if you're given grams and you're trying to get to moles, that's kind of where we're going with this. All right, the other thing you're going to need to know are your conversions. Now, conversions are just things that equal each other. So for example, there are 60 seconds in 1 minute. There are 4 quarters in $1. There are 4 quarts in 1 gallon. Like those kinds of things. Those are conversions. Two things that equal each other, where the numbers are different and the units are different. That's what we're looking for. And so then after you kind of know where you're starting and where you're going and what conversions you need, the next thing is that you set up your problem so that your units cancel. And that's using your math knowledge of, if you divide by the same thing, like 2 divided by 2, the 2's cancel out, or x divided by x, the x's cancel out. So that's what we mean by setting it up so that your units cancel. And then the last step will be just to solve. And we'll review that a little bit, but basically you'll multiply anything that's on the top of a conversion and divide anything that's on the bottom of a conversion. So let's walk through an example, so kind of to see that process. So the question might be something like, how many miles is a 5K race? So maybe you've thought about running a 5K before, there's something that seems to be kind of popular, and you've always wondered, well, how far really is that? So how many miles is a 5K race? So the first thing to figure out is, well, where are you starting? And where you're starting is that 5K, which remember really stands for 5 kilometers. So that's where you're starting. That's what we were given. That's the information we're starting with. That's what I mean by where am I starting. So what am I trying to get to? That's the thing it's asking for. So usually that's going to be in the form of a question or in a prompt, like go from 5 kilometers to miles, or how many miles. So the question part, what are you trying to get to? So we're trying to figure out how many miles that would be. So then the next question is, well, what are the conversions that I need? On your next handout, there's a whole bunch of conversions that will be useful, and eventually you'll basically just be using the periodic table for conversions. But for these intro practices, this next handout will have a whole bunch of conversions. So what we need to know is, we need to know the conversion between kilometers and the conversion to miles. And that's something that you can just look up. You don't have to have it memorized. So it turns out that 1.61 kilometers equals 1 mile. These two things are equal to each other, just the way that like 1 hour equals 60 seconds is equal to, or 60 minutes is equal to each other. And so it doesn't matter which one you put first, as long as the 1.61 always goes with kilometers and the 1 always goes with miles. So that's going to be our conversion. So now we do this thing where we set up our units until we get to the units that we want. So you start with your starting number. So you're always going to start with something that looks like this. And I like to put it in brackets to kind of organize my work. And then even before I go any further, I know there's going to always be a conversion. So I'm going to set up an empty bracket, because it kind of guides what I'm going to do next. Because now I see that I need to have something on the top and something on the bottom. And I know that the thing on the bottom has to cancel the thing that I'm starting with, or at least the opposite. If I started with something on the bottom here, I'd have to put it in the opposite spot here so that it cancels. So when things are on the top and bottom, they cancel. Well, now I'm going to go back to this conversion that tells me 1.61 kilometers equals 1 mile. So if I put this part, the 1.61 kilometers, if I put that on the bottom and 1 mile on the top, then look what happens. Kilometers divided by kilometers will go away. So kilometers cancels. the numbers don't cancel because I don't have the same number anywhere. So then what I will do is, to solve this problem, because I'm left with miles, which is what the units were that I was looking for. So then now all I need to do is solve my problem. I multiply numbers on the top, I divide numbers on the bottom. So I'm going to take 5, and then if you want to, you can do the times 1. It doesn't change your math, but if you like to have it for consistency. And then I'm going to take divided by 1.61. And then that ends up with this. So I get this really long number, and this is just your calculator doing as much math as it can. We really want to think about the fact that, okay, none of these numbers were very many decimal places, so our answer, maybe we're going to round it off to 3.1. And then the label is miles because that's the only thing that's not crossed out. And then this becomes our answer. So if you've ever wondered how far a 5-kilometer race is, it's about 3.1 miles. So that gives you sort of an idea of how to set up these DA problems. So just a couple reminders about this. So you remember, make sure that you show all of your work. This is what I mean by showing your work. Show all of the conversions that you're using, and then no naked numbers, meaning you've got to have a label on it, because if I didn't know this was miles, I wouldn't know what label to put here. If I didn't know this was kilometers, I wouldn't know to put it on the bottom so that it cancels. So that's going to be sort of an important thing to remember. The other thing is that your math reminder, so anytime you are setting up fractions or ratios or equivalents, which is what this is a fraction or a ratio or equivalent, to solve them, you multiply anything that's on the top, you divide anything that's on the bottom. This line in math means divide. So anytime there's something underneath it, you need to hit divide on your calculator. All right? You can also sort of think of dimensional analysis like solving a puzzle. You've got a starting place, you've got an ending goal, you've got to fill in the pieces in between. So to kind of get that idea that, okay, it's sort of like solving a puzzle, I want you to try these next 3 problems. If you have someone you can work with, go ahead. Otherwise, just keep working through this by yourself to solve these math problems using DA. So here's your first example. How many centimeters are in 18.5 feet? So this is what my question will look for. So remember, the steps are, where am I starting? What units am I trying to get to? What conversions do I need to use? And then solve. So in all of these examples, I gave you the answer. We just got to see if we get something that makes sense. So we need a starting place. That's always going to go in your first blank. Well, our starting place was given to us, 18.5 feet. So let's go ahead and try that out. So 18.5 feet is our starting place. Now, at the end, I want to know how many centimeters there are in 18.5 feet. So I've got to somehow get from feet to centimeters. That's my ending goal. So I know that when I'm done with my problem, I should be at centimeters. So let's figure out how we can make that happen. We need some conversions. Well, I want a conversion that's going to get rid of feet. Well, I know that there's 1 foot equals 12 inches. Okay, well, that's going to cancel feet. So let's go ahead and use that. So I'm going to fill this in. I'm going to put feet on the bottom, 1 foot, because remember, I need to have it in the opposite place so that it divides and cancels. Well, 1 foot is equal to 12 inches. You can only put stuff on the top and bottom of a ratio if they equal each other. Because look at, now feet divided by feet will cancel. I'm left with inches. The problem was asking for centimeters, so I'm not done. So now I have to look for something that has inches in it. Oh, well, look at here. 1 inch equals 2.54 centimeters. All right, well, I can use that. The 1 inch has to be the thing that cancels, so that's going to go on the bottom, because when you have things in the opposite place, top and bottom, they cancel. Well, 1 inch is equal to 2.54 centimeters. So then now, once again, inches divided by inches will cancel. The only thing I'm left with is centimeters. That matches my answer. So this is a pretty good indication that I set it up right. Well, now let's go ahead and solve it. So let's clear this out. So you multiply everything on the top, divide anything on the bottom. So I'm going to take 18.5 times 12 times 2.54. All right, and again, your calculator just kind of rounds out as much as it can. So this number had 3 numbers, this had 2, this had 3, so our answer rounded off to 3. So then this ends up being mathematically in science about the same answer. So this is an indication that we did it correctly. All right, so seeing that example, another example, now what I want you to do is pause the video, and I want you to see if you can set up problem number 2. So take a break, go see if you can set this up, and see if you can get the answer that it says that we have here. Ready, go. All right, welcome back. So you tried the problem, maybe you got the right answer, maybe you didn't. If you got stuck, let me go ahead and set this up for you, and you can just see if it makes sense. I'm starting with 3.5 years. I want to know how many hours that is. All right, so I've got a starting place, so I'm going to start with 3.5 years. But then I need to get all the way to hours. Well, what's something I know that's equal to hours? Well, days are equals to hours. What's something that's equal to days? Well, let's see. I could go from years to days. That would work. So then what I could do is I could say that in 1 year, there is approximately 365 days. And I realize that it's really 365.25 or something because of leap year, that kind of stuff. But I can use this as my conversion. Years goes away, I'm left with days, but I'm trying to get to hours, so I have to keep going. Well, I happen to know that in 1 day, there are 24 hours. So then what I can do is I can cancel days, and then I'm left with hours already, so I don't even need this conversion, so I can just get rid of it. So if you had gone from years to months to days to hours, or years to weeks to days to hours, something like that, that's maybe why you would have used another bracket. But let's see, the answer is supposed to be somewhere around 31,000. So let's see if I get that. All right, so let's multiply on the top. So 3.5 times 365 times 24 equals, if I round this, it's 30,660. If I round that up, that would be 31,000. And then the label is hours because that's the only thing that's not crossed off. All right. So, and we also take a moment to think if that makes sense. We ended up with a really big answer. Well, yeah, that makes sense. A lot of hours would fit into 3.5 years. So my answer makes sense. My setup is all good. We did it right. All right, go ahead and pause the video one more time. And now I want you to try to do practice problem number 3 by yourself. Go ahead. All right, welcome back. Hopefully you have a chance to look at it. Hopefully you got the right answer. If not, let's take a look at this one together. How many grams are in 135 pounds? All right, so I have to have a starting place. The starting place is what you were given. I was given 135 pounds. All right, but the problem is looking for grams. So I need some conversions between pounds and grams. So either you looked it up on the next page, or of course I gave you some right here. I can go from pounds to kilograms, so then that will cancel pounds, so let's use that one. So when I set up my conversion, I always want the thing that cancels in the opposite spot. It's on the top here, so it'd have to be on the bottom down here. So I'm gonna put 2.2 pounds on the bottom. And whatever it's equal to needs to go up top. Well, it's equal to 1 kilogram. So I put 1 kilogram on the top. Pounds will cancel because they're in the opposite spot. That's always the idea. Top and bottom cancels. All right, so now that I have that taken care of, I'm at kilograms. But remember, the problem was asking for grams, so I'm not done. Well, I happen to know from my metric conversions that there's 1,000 grams equal to 1 kilogram. So I can set that up down here. Kilogram is what needs to cancel, so since it's on the top here, it needs to be on the bottom here. So 1 kilogram goes on the bottom. 1 kilogram is equal to 1,000 grams. Kilograms cancel. So now the only thing I will be left with is grams. That's what the problem was asking for, so I'm ready to solve. Multiply everything on the top, divide everything on the bottom. So I'll take my 135 times 1, or you can skip that, but then times 1,000, that I need there, and then divided by 2.2, and then divided by 1, which again, you can skip that one if you want to. So I end up with 61,363,6363, etc., etc. Okay, so then this rounds off, so 61,400. So 61,000, the 3, the 6 rounds that up, 2 places there. Yep, so 61,400. So with rounding, kind of paying attention to that, none of these numbers were very specific, so I can't be this specific with my answer. That's kind of the science part of it when we get our calculator numbers. That's the setup. All right, so hopefully that made sense. You see the pattern that it's always top and bottom. For canceling units, that's kind of the puzzle idea. And then the conversions, you just come up with one step at a time until you get the units that you're looking for. All right, so now what I want you to do is I want you to work on the next handout, which has you go through some actual practice problems on your own before we introduce the chemistry part of it. Thanks for listening.